Most electrical engineers design power systems that are disasters waiting to happen. Yes, they design power systems that are disasters waiting to happen. Now, why is this? It's simply because they skip one of the most critical studies, short circuit analysis. They think, okay, we've selected the breakers, we've carried out our load flow analysis, so we should be good to go. But here is the harsh truth. If you haven't verified the fault current at every bus bar, your entire system could fail the moment a real fault occurs in the system. Hello and welcome back. My name is Jesse from JP Smart Solutions Ltd. And today we are actually exposing one of the most overlooked, misunderstood, and dangerously ignored studies in power system design, which is short circuit analysis in power systems. Now, by the end of this video, firstly, you will know what short circuit analysis really means, not what short circuit analysis means to most engineers. So we are going to be explaining the fundamental concept and objectives of short circuit analysis, not what most engineers think. We are also going to be explaining why skipping it can destroy equipment and reputation. So short circuit analysis is not just for your equipment, it is for you, the design engineer. We are also going to be giving practical insights on how ETAP software can be used to perform short circuit analysis and how ETAP software makes it impossible to ignore the truth. And just a heads up, this video will step on a few toes. But then it's better to be uncomfortable now than to face an explosion later on. So let's dive right into it. Short circuit analysis. So the big question is, what is a short circuit analysis? Now, let's get one thing straight. A short circuit analysis is not optional. It's not something you do later. It's the foundation of safe design. Yet, I've seen too many engineers rely on rule of thumb breaker sizing or copy paste specs from old projects without ever checking if those breakers can actually interrupt the actual fault current. Now, this is engineering malpractice. Yes, engineering malpractice. So then, what is this short circuit analysis really about? Short circuit analysis is the calculation of the currents which flow when faults of various types occur in a power system network. So it is about knowing exactly how much current will flow when something goes wrong. And trust me, something will definitely go wrong. So on power systems, we have various types of faults which we can classify into symmetrical faults and asymmetrical faults. So basically symmetrical faults are for three-phase faults, that is a fault involving all three phases or all three phases and ground. While asymmetrical faults are examples line to ground, line to line, double line to ground faults. So what are the objectives of carrying out a short circuit analysis? Objective number one, we carry out a short circuit analysis to determine the maximum and minimum short circuit current for symmetrical and asymmetrical faults. Remember, we said symmetrical faults are faults involving all three phases of our power system. Asymmetrical faults do not involve all three phases. So short circuit analysis will help us to know the maximum and minimum short circuit current for these faults. The next objective, short circuit analysis, helps us to determine the rated interrupting capacity of our circuit breakers. Very important. Next, it helps us to investigate the operation of our switch gears, our protective devices, our circuit breakers, our fuses, our relays. Short circuit analysis also helps us to determine fault current distribution and bus bar voltage levels during fault conditions. Now, imagine you installed a breaker rated for 25 kiloamps, but then the real fault current is at 35 kiloamps. What do you think will happen? Of course, the breaker will blow apart. The equipment will burn. People will get injured. And guess the first question that will be asked during the root cause analysis investigation. Did you carry out a short circuit analysis? And you, the design engineer, will be responsible for responding to this question. Did you carry out a short circuit analysis? Because if you carried out a short circuit analysis, you would have seen this problem, you would have avoided this problem. All right, let me share an instance. A contractor installed a brand new low voltage switchboard for a client. Now, as usual, everything tested fine, insulation, continuity, all good. But then, when a cable fault occurred, the circuit breaker exploded like a grenade. Why did this happen? A root cause analysis was carried out, and it was observed that the available fault current from the utility was 30 kiloamps, while the breaker was rated at 18 kiloamps. That was simply the problem. Now, they skipped short circuit analysis to save time, and that shortcut cost them over $10 million, including a lawsuit. This is what happens when you design without carrying out a short circuit analysis. So, moving on, why is short circuit mandatory? Why is it compulsory? Why is it crucial? Now, here's the uncomfortable truth. Many engineers do not know how much fault current their systems will produce. They are not aware of this. They just assume, oh, it should be fine. We used the same design last year. But then they tend to forget that power systems are not static. The moment you change one transformer, or you add a motor, or you increase the utility capacity, your fault levels change instantly. Now, this is why standards such as the IEEE 242, the IEC 60909, and the NEC all mandate fault analysis. It's not a suggestion, it is a requirement. Ignoring short circuit analysis means your protection settings are unreliable. Ignoring short circuit analysis means your breakers may fail catastrophically. Ignoring short circuit analysis means that your entire design may collapse under fault conditions. Now, At JP Smart Solutions Ltd, our aim is to ensure you become professionals or specialists in power system design, analysis, optimization, and protection. So in professional practice, you do not guess, you calculate. Short circuit analysis actually tells us how much fault current or how much current flows during each type of fault, be it a symmetrical fault or an asymmetrical fault. Short circuit analysis tells us whether or not the breakers and fuses are up to the task. It also tells us which equipment is dangerously underrated. So if you are not carrying out a short circuit analysis, then you are hoping, not designing a power system. Now, let me show you what real engineering looks like. Switch over to ETAP Software. All right. So we have a simple power system over here. We have our utility here, which supplies this bus bar, and we have two transformers. This is a spare. This is the main transformer, which supplies the two transformer. It steps down the voltage from 33 kV to 11 kV, while this transformer steps down the voltage from 11 kV to 0.415 kV, on which our loads are connected at this point. We have a bus coupler here. We also have a backup generator over here with a distribution panel here. And we have an on-grid solar system supplying power to the grid over here. So, on this system, we are going to carry out a short circuit analysis on this simple system. And once we are on short circuit mode, we're on short circuit, we just need to select the system we want. As we've selected these buses, we want to carry out a short circuit analysis on the entire system, and then we'll click on run. It's that easy. But first, you need to know exactly what you're doing. So I'll start with the device duty calculation based on IEEE 60909 standard. Once I click on this, we can see it is showing us the fault current magnitude at each bus bar. For example, we can see this guy over here is 28.643 kiloamps. This is 29.209 kiloamps, and so on, distributed all around the system. Also, these device duty calculations checks if our breakers are adequately rated. If not, it flashes red. No guessing, no assumptions. For example, we can see over here this breaker, let me zoom in. This breaker is flagged red. This breaker is not flagged red. This breaker over here is flagged red, meaning there's a problem. We go down, let's see other parts of the system. These breakers are flagged red, meaning we have problems. So we can tell, we can identify these problems even from the design stage. Without implementing it, we can see that, okay, these breakers have problems, we need to work on it. Now, ETAP doesn't just stop at telling you that they have problems. It tells us the precise problem we have. But then we'll be going into that in details much more later. So, we've been able to carry out a short circuit analysis. We can also identify three-phase faults, symmetrical faults, or asymmetrical faults. We can just simply run this IEEE 60909, and we can see the fault contribution voltage magnitude at various sections. Now, if we wish to see the different fault types, we can choose to see the results for a three-phase fault, a line-to-ground fault, a line-to-line fault, and a line-to-line-to-ground fault. So, ETAP is very much robust for short circuit analysis. And ETAP's built-in standards ensure your results align with ANSI or IEEE standards. Now, in our ETAP professional training, we go deeper, much more deeper. We teach you precisely how to use IEC 60909 standard correctly, how to assess symmetrical versus asymmetrical faults, and how to generate reports your clients and auditors will trust. This is what separates professionals from pretenders. Let me share one more experience. A manufacturing plant upgraded their incoming transformer to meet growing demand. But then, here's the catch. No one updated the short circuit study. Guess the result? Now, the new transformer increased the available fault current from 22 kiloamps to 38 kiloamps. However, the existing switchgear was rated 25 kiloamps. So during the first fault event, there was total failure. Now, the downtime was for 3 days. The repair cost was for $20 million, all because someone said it's just an upgrade, no need for new studies. This is the cost of ignorance. So here's the final truth. If you are yet to run a short circuit study, you do not know if your power system is safe. You are hoping that your breakers will hold. You are trusting your equipment ratings. But in engineering, hope is not a design method. A short circuit analysis is not just for formality. It is an insurance policy against disaster. And ETAP makes short circuit analysis fast, not just fast, accurate, not just fast and accurate, also globally compliant. Now, if you want to learn how to carry out a short circuit analysis properly, join our ETAP training at JP Smart Solutions Ltd. Now, we don't teach theory, we teach real engineering with real systems and real results. You can click the link in the description, or you can actually send us a message using our contact details over here. You can call, WhatsApp, or send an email. I will respond to you as quick as possible. Stop designing blind and start designing with confidence. Thank you so much, and see you in our next video.